My name is Dr. Kenneth Christie. I'm the Director of the School of Humanitarian Studies at Royal Roads University, and I am the Acting President of the Confederation of University Faculty Associations of British Columbia, or CUFA BC. CUFA BC is the provincial voice for more than 5,500 university professors, instructors, lecturers, and academic librarians at the 5 research universities across the province: Royal Roads University, Simon Fraser University, the University of British Columbia, the University of Northern British Columbia, and the University of Victoria. I would like to acknowledge that the land on which CUFA BC's office resides is on the traditional, ancestral and unceded territories of the Coast Salish peoples, including the Squamish, the Tsleil-Waututh, the Musqueam and the Stolo nations. We offer our respect to their diverse histories, cultures and enduring connections to this land. Today we are proud to celebrate the recipients of the 2026 CUFA BC Distinguished Academics Awards. These awards recognise outstanding scholarship that extends beyond the academy, work that meaningfully contributes to our communities and public life. Across British Columbia, faculty are advancing knowledge in ways that shape policy, drive innovation, and deepen our understanding of the world. While much of this work happens outside the spotlight, its impact is profound and far-reaching. These awards provide an important opportunity to recognise that contribution. It is my pleasure to present the 2026 CUFA BC Early in Career Award to Dr. Anne-Sofie Ahm. This award recognises significant contributions to the broader community by faculty members who are early in their careers. This recognition reflects the respect and admiration of colleagues across institutions, disciplines and communities. Dr. Ahm joins us to talk about her research.
My name is Anne-Sofie Ahm. I'm an assistant professor at the School of Earth and Ocean Sciences at the University of Victoria.
I was wondering if you could tell me about your research interests.
Yeah, so fundamentally, I'm interested in the history of our planet. And that goes all the way back to the evolution of life, from the first single-cell organisms to the evolution of animals. And actually what I'm really interested in is the co-evolution of life and climate. So how has the environment and life shaped each other through time?
Now, you're recognized for your work in developing a revolutionary new approach to carbonate Diagenesis. Could you tell me about your research to see through the geological noise and reconstruct Earth history?
Being interested in Earth history and specifically really deep time is problematic because we don't have any records of what happened on Earth 1 billion years ago, for example. So what I study are carbonate rocks, and these were originally sediments that formed on the seafloor as layers. And over time, these layers have been compressed under higher temperatures and pressures and eventually turned into rocks that we can go and we can sample today. So these rocks contain hidden clues of what happened on Earth in the past. But through this process of being turned into a rock, so being compressed and heated up, the chemistry has changed. And that's what carbonate diagenesis means. It's that process of turning those sediments into a rock. And so if we actually want to create robust records of what happened in the past, we need to sort of disentangle that noise that has been incorporated into the record. So that's what I do. That's what my group does.
Your nominators describe you as someone who has broad collaborations with an impressive diversity in topics. One said you were an international class scientist, insightful, fearless and relentless. Why should people care about carbonate diagenesis?
Yeah, so I think collaboration is absolutely essential to solve hard problems in science. We are standing on the shoulders of giants, so to say, and so actually getting a lot of minds to work on hard problems is essential. When it comes to doing fundamental science, sometimes it's hard for the public to understand why should I care about these really old banged up rocks that you're looking at. And I think there are many reasons. One is just understanding the physical world around us and deepening our knowledge of the history of our planet. This is not only relevant to planet Earth, it's also relevant to understanding the universe and the potential evolution of life on other planets. What should we be looking for a habitable space, a habitable planet? The other thing that's more down to earth when it comes to studying carbonate diagenesis is that fundamentally that process is the reactions between minerals and fluids in the subsurface. And that's actually also what generates ores and critical minerals, which is essential to the economy of BC. It's also essential to our green transition to cleaner energy sources. And finally, I will say why diagenesis is really, really important for these carbonate rocks is that's actually the ultimate sink of CO2 from Earth's surface. So carbonate rocks are made of calcium and carbon, and it's actually 80% of all carbon eventually leaves Earth's surface in carbonate rocks. So understanding this long-term sink of carbon is really important for understanding how we could potentially lock away carbon from the atmosphere. So when it comes to work on CO2 storage, capture and storage, what we really want to figure out is how can we take CO2 from the atmosphere and stick it back into the earth in the form of a carbonate rock.
Your nominators were impressed by how quantitative and thorough your work is, saying you show remarkable patience in figuring out the right answers. They also said that your research in isolating the isotopic composition of seawater and the diagenetic fluid opens up entirely new ways of thinking about the geochemical signature of carbonates. Where do you see this research going next?
Yeah, so since starting at UVic, one of the things we've been doing is building a new geochemistry lab. And we have gotten funding to build this state-of-the-art metal isotope lab. And we have acquired an instrument which is called a Sapphire. So this is a multi-collector inductively coupled plasma mass spectrometer. And what it can do, it can measure the mass of metal isotopes. So for example, in a calcium carbonate, there is 40% calcium. But this machine can measure not just how much calcium, but how much calcium with mass 42, mass 43, mass 44. And that type of geochemical information is opening up whole new ways of understanding how these rocks have been altered. And it will allow us to make even better and more accurate models for this process of carbonate diagenesis, which ultimately unlocks deep time. We can go even further back, attack even harder problems, and understand what happened on Earth, not just millions of years ago, but billions of years ago.
And thinking about your career to date, how many EDI principles have influenced the way you design your research and teaching philosophy?
Yeah, so EDI is absolutely essential for science. The diversity of thought and perspective and experiences is what it takes to solve hard problems and move science forward. And it's also what makes science relevant to society. Unfortunately, in my field, in earth science, diversity actually hasn't changed for the past 40 years, especially at the faculty level. And so I see one of the most important missions for university professors in geoscience is to change that narrative. And so one thing we do, of course, is start from the bottom and think about the composition of our research team when we're hiring graduate students and postdocs. But not only thinking about hiring practices, but also thinking about making people stay in the field. So thinking about what are some of the barriers to participation in our field. So my group, we do a lot of field work, for example, and there's a lot of barriers to participation in field work. Not everyone can just go to some remote location and camp for a month. That's not for everyone. So we think a lot about how we can make that more inclusive and make sure we're not excluding people, especially people that historically have been excluded for this type, from this type of work.
Thank you. So we focused mainly on your research, but you're also a teacher and a mentor. In your teaching, what would you say is the most important message you want your students to take away from their studies with you?
So I think what I really want to teach is critical thinking, but it's also the hardest thing to teach. How do you make people think, especially in this day and age where critical thinking is kind of not a thing that young people like to do. Information is right at the touch of a button, right? ChatGPT will tell you the answer to anything. And that instant gratification, I feel like as a teacher, I'm fighting against that. When I ask my students hard problems, they really don't want to think about it. But I also think it's the greatest joy as a university teacher when you actually guide a student through that process and you see them when they get it, that light in their eyes, when they had to do something hard, but they did it at the end and they actually got the right answer.
Is there anything else you'd like to say to the nominators or the CUFA BC selection committee?
Well, thank you so much to my nominators for nominating me and for their support, and also thank you to CUFA BC for this amazing award.
Well, thank you for joining me today again to talk about your work. I want to congratulate you again on being awarded for the 2026 CUFA BC Early and Career Award as part of our annual Distinguished Academic Awards series, and I look forward to your successes at the University of Victoria.
Thank you.